Assalamu alaikum warahmatullahi wabarakatuh. Hello, my dear students, and this is our new lesson, projections. What is projections? Projections, we can represent it as a shadow of the sun. Over there, anything we want to find, it's a projection. Such that, like, if we have a point and a straight line, the projection of the point over the straight line is the location of the intersection point of the perpendicular line from this point to the straight line. So this point, maybe its name A. So A dash is the location of the intersection of the perpendicular line from the point A to the straight line L. So the projection of a point over the straight line is a point. And now the projection of a straight line segment over a straight line, if we have a straight line which is named L, and we have a line segment which is named XY, the projection of XY over the straight line which is named L, if you want to find its projection, you are going to draw a perpendicular line from X to the straight line L, and another perpendicular line from Y to the straight line L. And then the intersection points X dash, Y dash can determine the projection of the line segment XY over the straight line L. So it's X dash, L dash. So the projection of a line segment over the straight line is a line segment also. But the line segment has many cases, such like that. If the straight line has this position, so its name is XY, and we want to find its projection over a horizontal straight line which is named L, and then you are going to find the projection of the point X over the straight line by drawing the perpendicular line from X to the straight line and drawing the perpendicular line from Y to the straight line. Then we have X dash, Y dash is the projection of the straight line, the line segment XY. So you can say that X dash, Y dash, its length is less than the length of XY. You can say that the projection of XY is X dash, L dash, and its length equal to the original line segment XY. And you can say another position for the line segment XY, we have the straight line L, and we have the line segment in this position, this vertical position, and its name is XY. You're going to find the perpendicular line from X to the straight line which is located in the point X dash, and the perpendicular line from Y to the straight line which also is located on X dash. So the projection of XY line segment is a point over the straight line which is named L. And now we are going to find the projection of a ray over straight line. If you have the ray X, Y, and you want to find its projection over the straight line which is named L, you are going to draw the perpendicular line from X to the straight line and the perpendicular line from Y to the straight line, and then perpendicular line from another point which is named Z to the straight line which is named X dash, Y dash, Z dash. Yes, you are going to get another ray which is named X dash, Y dash. So the projection of a ray X, Y is another ray over the straight line which is named X dash, Y dash. So the ray can take another position such like that, X, Y, and the straight line which is named L, and then we have X dash and Y dash, and then another point which is named Z. So we have Z dash, X dash, Y dash, Z dash. So it gives me also a ray from X dash to Y dash which is named ray X dash, Y dash. So the projection of ray over a straight line is a ray, but the projection of a line segment over a straight line can be a line segment or can be a point like this position. That's very good. Let's move to our questions today. Page 88, practice 1. In the opposite figure, measure of angle B equal measure of angle ACD, which is equal 90. So this angle C is 90 and this angle B is 90. And now we want to find the projection of AD on CD. AD, where's AD? This is ED, it's a line segment. Yes, and we want to find its projection on the straight line CD. So imagine that we have a straight line CD which is horizontal, in horizontal scale, and we have the line segment which is named AD, and we want to find its projection on the straight line CD. So we're going to draw a perpendicular line from A to CD, to the straight line CD, which is AC. Yes. So C is a projection of A over the straight line on the straight line CD. And D lies on the straight line itself. So its projection will be itself. So DC is a projection of the straight line DA on the straight line CD. Again, the line segment CD is a projection of the straight line AD on the straight line DC. So the projection of AD line segment on the straight line CD is CD line segment. The projection of AC on CD, where's AC? This is AC. Where's CD? This is CD. AC in a vertical scale. So its projection will be a point and it will be C. So is a point C, the set of C. The projection of AC on AB straight line. Where's AB straight line? This is AB straight line. And you want to find the projection of the line segment AC. So the projection of A, this is straight line AB. And you want to find the projection of AC on the straight line AB. So the projection of A is itself because it lies on the straight line. And the projection of C is B. And then you can say that AB is a projection of AC on the straight line AB. AB line segment, or the line segment AB. Practice 2, in the opposite figure we have an isosceles triangle. AC equal 5 and BC equal 6 centimeters. Then find the length of the projection of AB on BC. Where's AB? This is AB. And we want to find its projection on BC. Where's BC? It's the straight line which is in horizontal scale, which is named BC. And then you are going to say that B is a projection of itself because it lies on the straight line ABC. So the projection of the point A, we are going to draw a perpendicular line from A to the straight line BC, and the location of the intersection point of the perpendicular line drawn from A to the straight line BC will be the point E, for example. So AB is a projection of AB over or on the straight line BC. So its length equal in the isosceles triangle equals 3 centimeters. Why? Because it bisects the base. The base equals 6 centimeters, so it's half equals 3 centimeters. So the length equals 3 centimeters. The area of the triangle ABC, half base by height. But we don't know the height, but we can find it. This is 3 centimeters, and this is right angled triangle, and this is 5 centimeters, so it's 4 centimeters. So the area of the triangle will be half base by height, half base which is equal 3 by height which is equal 4, 3 by 4 which is equal 12 squared centimeters. Practice number 3 in the same page. In the opposite figure, AB, the intersection CD, which is equal E, and E is the midpoint of CD, and AC equals 16, and EE equal 20 centimeters, and BD equal BE equal 10 centimeters. So this is 20 centimeters, and this is 16 centimeters, and this is 10 centimeters. So we can say that EE is 10 also, and we can find the length of EC by Pythagoras theorem. You will find that this 16 is 4 by 4 and 20 is 4 by 5. So we have here 4 by 3 by Pythagoras theorem, which is equal 12 centimeters. So this is 12 centimeters also. And then find the length of the projection of BD on CD. Where's BC? Where is BD? BD is 10 centimeters. It's a projection on CD. You're going to draw a perpendicular line from B to the straight line CD. And this is an isosceles triangle, as we said before in the previous example. We found the base is half 12, which is equal 6 centimeters. So its projection will be DEF مثلا, for example, which is equal 6 centimeters. So it's 6 centimeters. It's the projection of BD on the straight line CD. And the length of the projection of ED, where's ED? AD, A. AB, yes, AB, the whole of AB on CD. AB is divided into two line segments. At first, the line segment BE, and then the line segment AE. The line segment BE, its projection is FE, which is equal 6 centimeters. And the projection of AE is AC, which is equal 12 centimeters. So we have 6 plus 12, which is equal 18 centimeters. Okay.